What was the answer?
Pardon?
What was the answer?
Was it A?
Well, it's the same as the thing that Drew, so I can't remember.
Yes, it's A. That's exactly what we do.
Alright, since I'm done with exam 3, I'll go to exam 2.
I just have to go back and do what I did for exam 3, which is go back, write all the reactions down. That's what I did. And all the reactions includes the reagents, and then you see what they do. That's what I did, and that helped me so much. I used this like the whole time.
Yep. Knowing what the reagents do is a big part of it.
Can I take a picture of that after we're done?
Sure. It's just, I just went through the PowerPoint and just wrote down all the reactions that you can. I said you can do that to the others too.
Can we go 1?
Pardon?
Can we go 1?
One?
Yes.
On exam 2?
Yes.
Yeah. Water and a catalytic amount of sulfuric acid. So in general, when I have water and a catalytic amount of sulfuric acid and a carbon-carbon double bond, what are we going to do?
We're going to break it down.
You always tell me we're going to break it down, but that doesn't mean a whole lot to go. What are we going to do? Is that an addition reaction, an elimination reaction?
Elimination.
Are we going to eliminate something?
Double.
We are going to eliminate the double bond, but that's not an elimination reaction. Elimination reactions make double bonds. Double bonds like to undergo addition reactions. So what are we going to add across the carbon-carbon double bond? We're going to add a hydrogen. What else? What's going to get added across the carbon-carbon double bond? We're going to add water across the carbon-carbon double bond, right? So this is a way to make alcohols. You can take an alkene and you can add water across the carbon-carbon double bond using water and sulfuric acid. But it's a two-step process, it's a multi-step process, I should say, right? So we've got sulfuric acid, which you can think of as H plus and HSO4 minus. So the first thing that happens is the double bond picks up a hydrogen, right? And we generate a carbocation. That's the very first thing that happens. We'll balance everything out, okay? Now, water theoretically could just attack that, but that's a carbocation, so what's going to happen? Could happen. Rearrangement, right? This is a secondary carbocation. Anytime you generate a secondary carbocation, stop, pause, and ask yourself, can it rearrange to a more stable? In this case, it certainly can. There's a hydrogen here. And if that hydrogen moves, you get a more stable carbocation, a tertiary carbocation. Now the water attacks and you make that alcohol, plus of course you get your acid back because it's catalytic. Right? So the very first question I gave you was a rearrangement.
So then the opposite would have worked. So would that be the exact same thing for number 2? No.
Let me look at number 2. Number 2 is adding water across the carbon-carbon double bond, but in an anti-Markovnikov fashion using the hydroboration oxidation sequence. And so you're going to end up with the anti-Markovnikov alcohol, and there is no carbocation, so there's no rearrangements, right? So it is that's how we're adding the water. So you end up with C, looks like the right.
So so what's this mechanism? Oh, so that and,
So in the very first reaction, right, if you go back to the lecture, what you find is that the boron gets added at the least substituted carbon and the hydrogen goes to the most substituted carbon. That's what happens in step 1. In step 2, the hydrogen peroxide and base removes the boron and replaces it with the OH. So 2 steps. Pardon? Hydroboration oxidation.
rule states the carbon atom of the atom. That would be Markov's rule. Isn't Markov's rule the rule that states that carbon atom of an alkene with the most hydrogen atoms gets the hydrogen atom in the middle of APR, which is alkaline bromide?
Question 3, which rule states that the carbon atom of an alkene with the most hydrogen atoms gets the hydrogen atom in the addition of HBr to produce an alkyl bromide? That is Markov-Nikol's rule, yes.
I'm just going through step by step, just
Okay.
because we got the answers for exam 1.
You kind of do, don't you?
Yeah.
Because most of you redid that, right? So you got those.
Also on campus.
Yeah.
You work out solutions.
Oh, do it.
Yeah.
You got that one.
Yeah, they're
Yeah.
in there.
Yeah.
It's always counts.
I forgot I did that.
Yeah, like little explanations. on
Yeah, when
stuff.
you said that we didn't have answers, I was like, maybe you could just say that.
Can we go?
I forgot I did that, actually. Oh, well, I'm not going to go take it down now.
That's good.
It's too easy stuff.
I'm gonna leave Candace alone.
It's this exam, right? Exam one.
Really?
Yeah, because I was like,
That's pretty for it, but whatever. And that was my lowest score.
What else you got for me?
4.
Number 4.
He's gonna
Yeah.
go.
What about number 4?
What would be the final product of the following reaction? We'll get the problem below.
All right, so question 4. We're starting off with that.
All I did with that is I couldn't reference this one of them referenced and wrote down all the reactions. And then anything else I needed. That could keep turning out and so to add on to that, you can look at the other chapters and write down all their reactions.
How do you approach this problem? There's a couple ways you can do it, right? You can do it step by step.
I looked at
Or you
Lars.
Lars.
But Lindlar's was a telltale thing here, right?
Yes.
What does Lindlar's catalyst do?
It goes from, it'll go to the alkene.
Okay, so it takes an alkyne to an alkene, but what kind of alkene? Cis or trans?
Cis.
Cis, and which
Because
answer was that?
magnetic. That was B.
Because it picks one.
So B's the only right answer that you could have. All right, but let's see, if we didn't know that, right, how would we have solved this problem? Well, I know that these hydrogens are acidic. This is a base. So I'm going to end up with this, which is a nucleophile. So in the second step, it does an SN2 reaction, makes a carbon-carbon bond. And then Lindlar's catalyst, step 3, will take that to that, which is answer B.
Just remembering how stupid
Means you're learning.
No, so wait, so C's and, wait, oh, no.
I just tried.
So again, you really need to have a list of all your reagents and what they do. It's very very helpful.
I should listen to you guys.
Do you think I was lying?
Well, no, it's just like I ran out of time.
Ah.
I didn't plan, I mean, I spent 3 days, but that wasn't enough. So this last exam, I spent 5 days instead.
Yeah, we
And then I had more time.
We were at my house.
We were at her house and then we sat down, we're like, so we have nothing else to study. We studied everything.
That's good.
And then we were like, oh no, we're gonna fail.
I was struggling to.
Chapter 2, you're gonna have to remember, right? How to figure out whether something is R or S. Know how to use your model kits. The maximum number of stereoisomers, right, is 2 to the n, where n is the number of stereocenters. You're going to have to know your polarimetry, right? The equation for that is what?
Is that this?
Oh, it's that.
It's this, it's the, what I thought was a D and
yes.
it's actually an alpha. I thought it was Dobbs.
Dobbs? No,
I mean, it looks like,
it's an alpha.
it took me until after I did the test to realize. I was like, it's not.
So you've got to be able to manipulate that, right?
Yeah, that's not.
If I give you any of those things, you can always solve for the unknown,
Yeah.
right? In the example, I gave you an example of a sugar company or a candy cane company or whatever making candy canes for Christmas. Right? You did that.
Do you know number 6?
What's number 6?
That is a model kit.
Number 6, which of the following has the R absolute stereochemistry at the chiral carbon atom? All right. So when looking at that, what you need to do is eliminate anything that's not chiral. D is not chiral, so it can't be D. All of the others are chiral. And you have to build a model and then look at it, right? So if I'm looking at A, the hydrogen is going down, my OH is over here, my alkyl group and my methyl group, and so it's kind of going in the S direction when I turn the hydrogen away. It's going counterclockwise. So it's not A. So it's either going to be B or C. Both of those are amino acids now, right? So you should be able to answer that now. All of them have the S stereochemistry except cysteine, which is B, right? So the answer is B. There you go, Dakota.
B?
Pardon?
What's the answer, B?
It is.
Maximum, what's this student is at?
Stereocenters?
Stereoisomers.
That
The maximum number of stereoisomers is 2 to the n.
2 to the end?
Yeah, so if you have a molecule, I don't know, bromine, chlorine, fluorine, iodine, right? If you look at that, each one of these is a chiral center. So the maximum number of stereoisomers is going to be equal to 2 to the n, where there's 1, 2, 3, 4. So it's 2 to the 4th, right? So 2 times 2 times 2 times 2, 4, 8, 16 is the maximum number of stereoisomers for that particular molecule that I just drew there.
About this one.
Which one?
Bottom one.
Well, how many stereocenters does it have?
3.
So 2 to the 3rd, 2
6.
times 2 times 2. No, not 2 times 3.
8.
2 to the 3rd, 2 times 2 times 2 is 8.
Right now,
What number was that? It was 7?
that was 7. I'm going over the ones I know.
You're asking me to do the ones you know?
No, the ones I don't know.
Oh,
If you wonder why I'm skipping through like numbers, it's like
that's okay. Yeah, you skip.
there are 8.
8.
The jaws of Jesus fish.
Yeah.
What?
Well,
Alpha?
yeah, because the way you draw it looks like Jesus fish.
Oh, it does, doesn't it?
I'm not wrong. It looks like Jesus
It looks
fish.
like a D.
It looks like a fish.
Alpha. A tank car full of sugar solution was delivered to a candy company to make peppermint candy canes for the Christmas season. The company purchased the sugar solution with the understanding that the solution would contain at least 100 grams of sugar per liter. The candy company hired a chemist to verify the sugar content of the solution when it was delivered before they released payment. It is known that the specific rotation table sugar is plus 66.5 degrees. The chemist placed a sample of the solution in a polarimeter that has a path length of 1 decimeter. And they obtained an alpha observed of 10.1 degrees. What is the concentration in grams per milliliter that the chemist reported back to the company? Well, I'm going to use this equation, right? I'm looking for C,
So you have to,
right? So C is equal to alpha observed divided by alpha times the length, right? So that's 10.1, that's 66.5, and that's 1. So it's just 10.1 divided by 66.5, which whatever that comes out on your calculator. Just take 10.1 and divide it by 66.5 and you get the answer. And of course, there's some on there that you can eliminate right off the bat. Can't be a whole number, right?
Really like
0.150? Sounds about right.
As a, but, when I had a calculator, it was like 1.4, and that's not an option, so we're gonna.
so it'll be A.
Is it A?
E. What's rate equation uses S1 reaction?
What's the rate equation for an SN1 reaction?
Hydrogen and nuclear.
It's EK times haloalkane.
That's right. The rate is proportional to K times the concentration of the haloalkane. Yep.
And then,
Haloalkane, alkyl halide, I could have used any number of words.
yeah, no, I was wondering, this was, and the 10 is no answer for it.
Pardon?
10.
Can you repeat that?
No, 10 was, you look back in problem 9. So which of the rate expressions in problem 9 represents an SN2 reaction?
A.
Haloalkane times K is an SN1 reaction.
So then you would fill it out.
For an SN2,
Mhm.
what do you think it is?
Nuclear.
Huh?
I blacked out on that.
So an SN2 reaction has two things involved in it, right?
Mhm.
So it's the haloalkane and the nucleophile.
Yeah.
Yeah, you could use some people in overtime because there was no answer choices. I knew that, but there was like a point where like, I think like 2 people raised their hand and they went, there's no answers for 10.
But read the question.
Well,
It
you
said-
said go back to problem 9,
Yeah.
which, so,
I have trouble speaking English.
yeah, she was first. There's no answer choices for 10. So great. She didn't-
Which the following SU2 reaction would produce a fast
Yeah, so in an SN2 reaction, in terms of reaction rates, what happens as the alkyl halide goes from top to bottom? What happens to the reaction rate? It increases. Alkyl fluorides are essentially non-reactive. Alkyl chlorides will react, but they're slow. Alkyl bromides are better, and alkyl iodides are really fast. So the leaving group ability of a halide as you go down the periodic table gets better and better.
That answer my other, answer 11.
Pardon?
And answer 11.
And an answer to 11.
Yeah.
Yeah, that's what I
Yeah.
just, that's, yeah.
It's right here. It's the leaving group ability of these.
Yeah.
So as you go down the periodic table, it gets it's faster. So
So
it's not-
there.
and that's so if you need to look up on that, that's the.
Which of the following produce the reaction is
What else you got for me?
well,
Just gonna go to the example.
yes. And we'll pass over the ones that I do know.
I love watching you work. I second guess myself. Working out.
So 12. What is acetone in this reaction?
Breaks it down.
That's your default answer, Dick. Everything breaks it down. What is acetone? It's the solvent. What kind of solvent is it? Remember, we talked about different types of solvents when we were talking about substitution reactions. We talked about polar solvents, we talked about nonpolar solvents. But when we talked about polar solvents, we talked about polar protic and we talked about polar aprotic. This is polar aprotic. Polar aprotic solvents favor the SN2 reaction. Right? So I have a good nucleophile, I have a polar aprotic solvent, I've got a decent leaving group, this is going to be an SN2 reaction. My nucleophile is going to attack that carbon, that leaving group is going to leave at the same time, and so I'm going to end up with inversion of the stereochemistry.
Acetone reverses.
It reverses, yes. So that's whatever one, that is the right answer.
And 13 would be. What do you want?
Problem 12 says, which of the following is the mechanism for the reaction to problem 12? Is that an elimination?
No.
No, so it can't be an E reaction, right? So what is it? It is SN2, right? The nucleophile is attacking as the leaving group is leaving, right? So this is an SN2 reaction.
This one, boiling elimination. I mean, when you boil something, elimination.
High temperatures favor substitution or elimination? It is elimination. Yeah.
That's what it's called.
So on the next one, that answers your question. Which one would it be if it's elimination?
Big.
B.
High temps favor what? Elimination.
High temperatures, when you have to think about either like SN1 versus E1, higher temperatures favor the elimination, whereas lower temperatures favor the substitution.
So it would be E1.
Yes.
And when you're trying to name a molecule, you go from left to right. Right to left?
We're trying to name a molecule. How do we name a molecule? Do we go from left to right or right to left?
You go
What's
by,
the rule?
You go by the carbon.
Depends. You go by what's most important.
That's right. So you're going to find the longest parent chain. You're going to start there. You eliminate anything that doesn't have the longest parent chain, right? And then you will number your parent chain to give you the lowest possible number for the substituents that you can give it, right? Now, of course, carboxylic acids take priority in the numbering, and alcohols will take priority in the numbering, but everything else is just a regular substituent.
So 1, 2, 3, 4. 1, 2, 3, 4. Would these count as additions to this? So 1, 2, 3, 4, 5.
No, that's an alcohol.
1, 2, 3,
That's a hydrogen.
No, I don't think
5.
That is a carbon. 1, 2, 3, 5 is the longest chain.
So right here.
Circle. Yep, that's the longest chain. Yep. What else?
Yeah, just go for food. Why not? You know, we're there. Why not just, you know, there you go, buddy. Let's do 18. 18.
18?
Yeah,
18.
Strictly just don't write it down.
just so we can write it.
18. So we've got an alkene. We're going to do a two-step reaction. We're going to do water, sulfuric acid, catalytic amount, followed by chromium trioxide, sulfuric acid, and water. This really was a question about, do you know what your reagents are, right?
Yeah.
So chromium trioxide, sulfuric acid, and water is also known as Jones reagent. All right, so what's going to happen in the first reaction? We're going to add water across the carbon-carbon double bond. I made this one easy for you because there's, no matter how you put it on there, it's the same thing, so there's no way to get it wrong, right? So you end up with that alcohol. And then what does Jones reagent do to a secondary alcohol? Turns it into a ketone. Yep.
I always have to think about it.
Secondary alcohols get oxidized by Jones reagent to give ketones. Primary alcohols get oxidized by Jones reagent to give carboxylic acids. Primary alcohols get oxidized by PCC to give aldehydes.
In hindsight,
Looking back at this.
Any others? All right, well,
What was the answer?
study well.
Answer was the only one.
You can have all of your own handwritten notes. You can't write down the old questions from the stuff in your notes. Don't do that.
I'm not doing that. I mean, I know it sounds sarcastic, but it's serious.
I won't be there, so I wish you all the best of luck with it.
So the final replaces our total average,
Maybe.
if you will now.
If your final exam grade, let's say your final exam grade was an A, but your overall class grade, including everything, was a C, I will give you the A. You gotta have a little faith in yourself.
So you're, so,
You know, I have all the faith in the world, and then, you know, walking into every exam just dead.
so if I go B on the final, and you add the final to my grade, and my grade is still A,
You get the better than you?
Yeah,
but that's still.
and then I got the exam,
final
and
grade
I
is
like
A.
that, I'm like, well, that's.
The final grade is still
So
there.
now, good to
No,
know.
well, the problem is I have an A, so I'm smart when I think
I'm
about
like, well, you can't be surprised, because.
Well, let's do that math. So let's say you've got an A right now,
Yeah.
and you got a 50 on the final exam, which would be an F.
Yeah.
But if I throw that F in there and you had a B overall,
Yeah.
you get a B.
Yeah, the average, what I'm saying is that we know,
That's what legal.
we don't get the benefit of.
Why would, what do you mean?
Why would it not be legal? You know, you can do whatever you want.
So like, you're telling me that if somebody decided.
You want me to change it?
No, for the slight chance
and they
that I
get
could
A on the
possibly
final,
pull an
they
A
get
right
that
out of my
A,
ass.
even though they have a zero. That's recorded.
Theoretically, that's possible, but there's nobody in that boat.
Yeah, that's what my mom's telling me, and my mom, I was like, wait, he is. Because like, that'd be like awesome to do that.
I mean, we
That's like
calculated,
major impact.
we did, because the final exams, like with the grade things, we were calculating like how many points we would need to get on the final, like from the 150.
We would only need 50 points.
We would, 96 points is the minimum that we can, which I don't plan on doing.
Yeah, we do this like 27 questions.
Yeah, we can test 27 questions.
Which isn't happening.
Don't worry about all that. Just worry about knowing your stuff and let the grade take care of itself.
I need it for me.
I just need to know, let's just say good night.
You're gonna do fine.